Hi, I'm Ms. Matsuoka, and I'm going to teach you about how to find different properties of rational graphs. So we have different properties like the horizontal asymptote, we have the holes, vertical asymptotes, domain, and zeros. So those are the things that we're going to be focusing on. Now, first off, I'm just going to give a definition of each of these things. And I'm going to kind of talk about how I'm going to abbreviate these things because I'm probably not going to write all of them out completely. So for me, I'm going to write horizontal asymptote like HA. Okay, so I'm just going to abbreviate it as HA. This is my horizontal asymptote. Now, horizontal asymptote, first off, it looks like this. It's just a horizontal line. And asymptote is like where the graph gets closer and closer to it, but it never actually touches it. So when you graph it, it actually looks like this. It's a dashed line. And I'll show you about how to graph them later in a later video. So anyway, that's a horizontal asymptote. Now there's three types of things that can happen. So you can either get that you don't have any, so no horizontal asymptotes, and that's if the numerator, the degree of the numerator is bigger than the degree of the denominator. So this is degree on top is bigger than the degree on the bottom. Remember, degree is just talking about the exponents. So for example, right here I'm talking about like x squared minus 5x plus 3 over x minus 1. This is a perfect example of when the degree on the top is bigger than the degree on the bottom because I have 2 is bigger than 1. Okay? Now, we also have y equals 0. This is when the degree, this is reversed here. So it's when the degree on the top is smaller than the degree on the bottom. Okay, and this is basically this part flipped. So if I flip that part over, then the degree on the top will be smaller than the degree on the bottom. And then there's this different situation. There's one last situation. It's just like y equals a number. And this is when, well actually, let me make this a little bit more clear. Y equals really like the two leading coefficients divided by each other. So I'm going to say leading coefficient divided by leading coefficient. Because that's what we're doing. We're just dividing by the first two leading coefficients on the top and on the bottom. So this is the third situation where the degree on the top and the degree on the bottom are the same. They're equal. And so I can show you this part too. That's like if you had x squared minus 5x plus 3 over like 2x squared minus 7. So here, it's leading coefficient divided by leading coefficient. So my horizontal asymptote would be 1 over 2. Because the degrees are the same on the top and on the bottom. So it's just do the leading coefficients divided by each other. So 1 divided by 2, so it's y equals 1/2 would be my horizontal asymptote. So that's the horizontal asymptote. I'm going to talk about each of the other ones here, and then we'll start like putting things together. Okay. So that's my horizontal asymptote. I also want to talk about holes. So holes, it kind of looks like this. It really is a hole in the graph. And you find the holes by, as it says, what's being canceled. So you factor like the top and the bottom. So let's say you have like x plus 3 times x minus 2 over x plus 3 times 2. Well, the hole is going to come from x plus 3 because that's what you're canceling out. Next we have the vertical asymptote. The vertical asymptote, it looks like this. Okay? Again, the asymptote is where your graph gets closer and closer to it, but it never really touches it. And it's what's left in the denominator. So let's say I have that x plus 3 times 2 over x plus 3 times x minus 2. Those two are being canceled. What's left in the denominator is x minus 2. That's where my vertical asymptote is going to come from. I will talk later about the zeros and the domain a little bit more in depth when we actually do those problems. But for now, let's go ahead and start one. So let's see how this all works. We're just going to put everything together here. And so the first problem that we're going to do is y equals, it's going to be x plus 3. It's going to be over x squared plus 4x plus 3. The first thing that I want us to find is the horizontal asymptote. So we're looking at the horizontal asymptote first. I think it's just easiest to find the horizontal asymptote because it's either 0, there's nothing, or you just divide the leading coefficients. In this case, it's y equals 0 because the degree on the top is smaller than the degree on the bottom. So I have my horizontal asymptote. That's my first thing. Now I'm going to look at the holes. But in order to look at the holes in the vertical asymptotes, I need to factor the numerator and denominator. So I have x plus 3. It's being divided by this. I need to factor that. 3 goes on the top, 4 goes on the bottom, so it's going to be 4. And let's see. Sorry, that's not right. It's going to be 3 and 1. There we go. So it's x plus 3 times x plus 1. And now I just cancel out what they have in common. So in total, I end up with 1 over x plus 1. So remember, the holes come from what's being canceled. The x plus 3 was canceled. So I actually set the denominator, I set x plus 3 equal to 0. And I solve. So I subtract 3 from both sides, so I get x equals negative 3. Now the hole, remember what the hole looked like. The hole is a point. So if we have our x-coordinate, we still need the y-coordinate. So what I'm going to do is I'm going to plug this in to my simplified equation here, and that's how I'm going to find my y-coordinate. So it looks like 1 over negative 3 plus 1, that gives me negative 1/2. So in total, the whole is at, my x-coordinate was negative 3, my y-coordinate was negative 1/2. So that's the whole. Now I'm going to do the vertical asymptote. Remember, the vertical asymptote, it's what's left in the denominator. So if I look at that, this right here, that's what's left in the denominator. So I'm doing pretty much the same thing I did for the whole. I'm doing x plus 1 equals 0. Subtract 1 from both sides, I get x equals negative 1. This is my vertical asymptote. Okay? Now, my domain is just not equal to the whole or vertical asymptote. This is very similar to when I talked about the excluded values in the domain. The whole and the vertical asymptote, those are excluded values, so the domain just isn't equal to them. So it's just domain right here. It's just x is not equal to negative 3, right? I'm just looking at those x values, and x is not equal to negative 1. Alright, so that's my domain. And we are on to our last part, which is zeros. So to find the zeros, I set the whole thing equal to 0. Let me clarify that here. When I say the whole thing, I mean this simplified fraction here. So I'm setting this simplified fraction here equal to 0. And so I'm going to do that right over here. So I get 1 over x plus 1 equals 0. Now, somehow I need to get rid of this fraction. So I need to get rid of the fraction, which means I need to multiply both sides by x plus 1. So I multiply both sides by x plus 1. Those will cancel out. 0 times anything is just 0. So right now I have 1 equals 0. Can 1 equal 0? And the answer is no. 1 cannot equal 0. Like, no, one number cannot equal a different number. So this is actually no solution, which means that there are no zeros here. Alright, so that was our first example. I will give you guys a couple more, and then we'll do the bonus question. Here's our second example. So again, we want to find the horizontal asymptote first. So our horizontal asymptote here, again, we look at those exponents. We look at the degree of the top and the degree of the bottom. They're the same, so I'm going to divide the leading coefficient. So 6 divided by 1, so it's y equals 6. Okay, we are done with that first part now. Second part is we want to factor the numerator and the denominator. To factor the denominator, it's just the difference of two squares. So it's just x plus 1 times x minus 1. Now the numerator, we're going to factor with the x. On the top is going to be negative 60, on the bottom is negative 11. And this is like our hard factoring with x. So if you need help with this, you can definitely look at that other video I have up, which is titled, I believe, Hard Factoring with X. So we get that. On the sides, it's going to be negative 15 and 4. So we're going to factor by grouping. So it's 6x squared minus 15x plus 4x minus 10. We group these. I take out a 3x, I'm left with 2x minus 5, and that's a plus 2 on the outside, and then, whoops, 2x minus 5. Okay, so in total, on the top I have this 3x plus 2 times this 2x minus 5. Okay, now, wholes come from what's being canceled. Is anything being canceled? No, nothing's being canceled. So that means that there are no wholes. Okay, great. So no wholes. Now I'm looking at my vertical asymptote. So remember, the vertical asymptote comes from what's left. Well, because nothing canceled, everything's left. So I set them equal to 0. And I just solve. So I subtract 1 from both sides, I get x equals negative, x equals negative 1. Add 1 to both sides here, I get x equals positive 1. So here, my vertical asymptotes are x equals negative 1 and x equals positive 1. Alright, my domain is just not equal to the numbers from my whole and the vertical asymptote. So domain is just, well, since there's nothing in the wholes, we don't need to worry about anything coming from the wholes. So it's just x is not equal to negative 1 and x is not equal to positive 1. Okay. Remember, for zeros, I set the whole thing equal to 0. I usually want to set the simplified one equal to 0, but you can't really simplify that. So we're setting that equal to 0, so 3x plus 2 times 2x minus 5 over x plus 1 times x minus 1. We set that equal to 0. Remember, I need to get rid of my denominator, so I'm going to multiply both sides by that denominator, and that's just going to get rid of it, so that's kind of nice. Okay, so those will cancel each other out. In total, we have 3x plus 2 times 2x minus 5 equals 0, because remember, 0 times anything is 0. And I set each part equal to 0, so 3x plus 2 equals 0, and 2x minus 5 equals 0. Now I just solve. So I'm going to get x equals negative 2/3, and I'm going to get x equals positive 5 over 2. I just write them as points for my zeros. So it's going to be negative 2/3, 0, and it's going to be 5 over 2, 0. Alright, there we go. So that was my second example. I have one example left, and then I will give you your bonus question. Here's my last example before the bonus question. So again, we want to find the horizontal asymptote. So the horizontal asymptote, there is none because the top exponent is bigger than the bottom exponent. Alright, first one done. Next one, we just want to factor the top and the bottom. So to factor the top part, well, first off, you can kind of notice that they all have an x in common. So I'm going to take out an x out of all of them. And then it's x squared minus 2x minus 3. In the denominator 2, I can also factor out an x as well as a 3. So I'm left with x plus 1. Now, also in the top part, I can factor x squared minus 2x minus 3 with the x. So on the top, I get negative 3. On the bottom is negative 2. So on the sides, I get negative 3 and positive 1. So in total, I have x and then x minus 3 times x plus 1 over 3x times x plus 1. I can simplify this. So I'm going to simplify these two and the x's as well. So in total, I'm just left with x minus 3 over 3. Alright, let's look at those wholes. So the wholes, remember they come from what's being canceled. I canceled out the x's, so that means that x equals 0 here for the whole. I plug this back in here, my simplified version, in order to get my y value. So I get 0 minus 3 over 3. This gives me negative 3 over 3, which is negative 1 here. Alright, so my first point here, let me write it over here, my wholes. First point is 0, negative 1. The second point is coming from here, so that's x plus 1 equals 0. I'm subtracting 1 from both sides, so I get x equals negative 1. I plug that back in here, so that's negative 1 minus 3 over 3, which is a negative 4 over 3. So I get negative 1, comma, negative 4 over 3. So those are my two wholes. Now I'm looking at my vertical asymptotes. So remember, vertical asymptotes come from what's left. What's left is the 3. So can 3 equal 0? No, it can't. So that's why we don't have any vertical asymptotes on this one. Alright, now I'm going to look at the domain. So the domain here, remember domain is not equal to my x-coordinates for the wholes and the x-coordinates for the vertical asymptotes. Well, we don't have any vertical asymptotes, so we only really need to worry about the wholes. So it's x is not equal to 0, and x is not equal to negative 1. Alright. Lastly, we're looking at our zeros. So for the zeros, we set the whole thing equal to 0. So that's this x minus 3 over 3. We set that equal to 0. We multiply both sides by 3 in order to get rid of my denominator. So I have x minus 3 equals 0. I add 3 to both sides here, so I get x equals 3, which means my 0 is at 3, 0. Okay, and I am done with all 3 examples, so I will be right back with your bonus question. Here's your bonus question. You are finding everything here, so you're finding the horizontal asymptote, and then the wholes, and then the vertical asymptotes, and then the domain, and lastly the zeros. Make sure you find every single part, and feel free to look back in the video, feel free to refer to the steps that are on the side, especially feel free to look at the very beginning when I explain what all these things are. Alright, good luck!